statistics, whereby we say that in statistics is that branch of mathematics that deals with collection, analysis, interpretation, and presentation of data. Then from there we looked at the different types of data, where we looked at the discrete data, continuous data, and so on and so forth. From there we continued to look at the terms which are normally used in statistics, whereby we said that among the terms, we said we have what we call the mean, we have what we call the median, we have what we call the mode, we have what we call the frequency table, what we call the class interval, the class, or what we call the class size, the cumulative frequency table, the cumulative frequency, and so many others. So we look at them. Now we say now we have to look at now some of these terms one by one, whereby we started by looking at the mean of the raw data. Then we also looked at the median of raw data. We also looked at the mode of raw data. Today we are now going to look at the mean calculation of the mean using the action mean method, or sometimes we call it the working mean method, or we call it the arithmetic mean method. All of those terms describe one thing: action mean, the working mean, the arithmetic mean. So we can calculate the mean by using the assumed mean method. And in this case, we said that the assumed mean may be used to make the work easier and quicker when finding the mean of a distribution, especially when we are dealing with values which are very large. Here, what we do, we choose any value within the values or within the data. We choose any value and then we use it as the assumed mean or the working mean. Or sometimes we can even choose a figure or a value that is outside the data and then we use it as the working mean. So at the end we will obtain the actual mean, or we call the true mean. When you are dealing with the working mean method or the assumed mean method, what we do is there are some terms which we have to pay in touch with. One, we need to know what we call deviation. So in the table that you always draw, in order to calculate the true mean, we have to create a table for what we call deviation. And the deviation is obtained by the midpoint values, or what we call the class marker values, minus the assumed mean. That is to say, D is equal to x minus A, where x represents the class marker values, or the midpoint values, and then capital A represents assumed mean. So in that column, we shall have obtained values of deviation or deviations. So the mean of the distribution now can be obtained by the formula mean x bar. We will now be obtained by assumed mean, which is a plus assumed mean plus summation fb over summation f, whereby x bar represents the actual mean, or what we call the true mean. Then A stands for the assumed mean. Then F stands for the frequency, and then D the deviations. Meaning that we shall have to multiply the frequency values by the deviation values, and then we get their total. Their total is represented by sigma, the letter sigma, the Greek letter called sigma, and in this case we use it for total, for getting the total number of values. Then we also get the total frequency values, after which we divide the total of FD by the total of F. So what we get would be the values of the actual mean or the true mean. We can look at an example now on how we can calculate the mean by using the assumed mean method. Example. The example says the table below shows the weight in kilograms of 100 watt volumes. Where we have the weight in kilograms and then frequency. Calculate the mean using the assumed mean of 77. In this case, if we specify the value of the assumed mean, it means by all means you have to use that figure. So in this case, they want us to use 77 as the assumed mean. So in our table, we have the weight measured in kilograms. Then we have frequency. We have the frequency. So on the weight, we have 70, 72, then 73, 75, 76, 78, then 79 to 81, then 82 to 84, Then the frequency values are here we have 8, we have 10, here we have 45, then we have 30, and then we have 70. This is the table of values. So we want to calculate the mean using the assumed mean method. So in this case, our solution will be we draw a table of values. Our table will look like this. First of all, we shall have the weight measured in kilograms. We have the weight measured in kilograms. Then we shall have the midpoint, which is represented by letter X. Then from here, we shall have the frequency values. Then we now have D, or what we call a deviation. Now, which deviation is got by which deviation is obtained by X minus A. X minus A. And then lastly, we now have FD. So our table will look like that. So our weight, the values of weight are in form of a class. We have the first class, 70, 72, 73, 75, 76, 78, 79 to 81, 82, 84. Then we get the midpoint. To get the midpoint, we shall consider each of the classes. Now, in each class, the first figure represents the lower class limit. Then the other figure represents the upper class limit. Lower class limit, upper class limit. So when we are getting the midpoint, we add the lower class limit to the upper class limit, and then we divide it by 2. So in this case, we shall have 70 plus 72, which is 142. 70 plus 72. We have 142. Then that 142 we divide it by 2. When we divide it by 2, we shall get 71. 71. Then to get to the next midpoint, we add 73 to 75. So we shall have 73 plus 75, we get 148. Then we divide it by 2. We find that we get 74. 74. So, then to get the next one, we also add 76 to 78. 76 to 78. So 76 plus 78, we get 154 divided by 2. We get 77. 77. So from there, we shall find that here we shall get 80, and then here we shall get 83. In that respect, we will just continue in that form. Then, frequency values, these ones have been given. We have 8, we have 10, we have 45, then we have 30, and then 7. These are the frequency values. Then we can now get the deviation. Remember, they told us to use the working mean as what? 77. So our value of working mean, we shall put it up there as A. A is equal to 77. A is equal to 77. 77. So to get the value of D, we shall subtract. We shall say x minus A, 77. But the x values are 71, 74, 77, and so on. So we shall have 71 minus 77. 71 minus 77, we get negative 6. Then from here we have 77, 74 minus 77, we get negative 3. From here we have 77 minus 77, we have 0. 80 minus 77, we get 3. And 83 minus 77, we get 83 minus 77, we get 6. So these are the values of deviations. So after that, we can now calculate FD, that means F times D. So for F times D, the F values of frequency values are, we have 8. We are multiplying it by what? The deviation values. So 8 times negative 6, we get negative 48. 10 times negative 3, we get negative 30. Then 45 times 0, we get 0. 30 times 3, we get 90. 7 times 6, we get 42. After that, we now get the total of FD, which is represented by summation FD. So summation FD is equal to, we add all these figures here, whereby we have negative 48, negative of 48, negative 48, then plus negative 30, then plus 0, plus 90, plus 42, and we get now 54. 54. So the 54 is the summation of FD. Then we also get summation F. Summation F, the total frequency. We shall add all the frequency values, whereby we have 8 plus 10, we get 18. 8 plus 10, we get what? 18. We get 18. And then 18 plus 45. We find that we get what? 63. And the 63 plus 30, we get 93. 93 plus 7, we get 100. So frequency is equal to 100. That is the frequency. So after getting the frequency, we can now calculate the actual mean, which is represented by x bar is equal to by assumed mean plus summation fd over summation f, such that our x bar will now give us the assumed mean, which is 77, plus summation fd is 54 over summation f, which is 100. So that when we add, we shall have 77 plus 54 divided by 100, you get 0.54, and therefore 77 plus 0.54, we get 77.54. 77.54. So the 77.54 will be equal to the actual value of the mean, which is called the true mean, which when rounded off, it will be 77.5 as answer. So basically, that is how we can use the assumed mean method to calculate the mean. We can now look at the mode of group D data. The mode of group D data. Mode of group D data. We said that mode is the figure that appears common, or the most common figure in given data is what is referred to as mode. That is for the raw data. But for group data, mode is obtained by using a certain formula. The formula for finding the mode of group data is mode of group data is obtained by the formula L or L dash L1 plus D1 all over D1 plus D2 then times C, whereby this L1 is equal to the lower class boundary of the model class. D1 is the difference between the frequency of the model class and the one before it. D1 is the difference between the frequency of model class and the one before it. Then D2, this is the difference between the frequency of the model class and the one after it. Difference between frequency of model class and the one after it. Then C represents the class width of the model class, or class size. Sometimes you can call it class size, class width, class interval of the model class. So that's the formula for finding the mode of the what? Of the group D data. Then we can look at the median of group data now. We want to see how we can look at how we can find the median of group data. Now the median of group data is obtained by the formula median of group data. This one is obtained by the formula median is equal to L1 plus summation of F over 2. Sometimes we use N instead of summation F. So we can use sometimes factor N over 2 to mean the total frequency. Then minus the cumulative frequency before that one of the median class. So this one we can represent it by letter FB, which means the cumulative frequency of the median what? Class. All over Fm. Then we multiply it by C. Sometimes you can write this formula as median is equal to L1 plus a summation F over 2 minus CFB, where CFB stands for cumulative frequency before median class, over Fm. The Fm stands for the frequency of the median class, times C, where C stands for the class interval of the median class. So this is the formula for finding the median of the group data. We can now see how we can use this formula in our calculations. Let's look at an example. The table below shows the marks obtained in the end of year exams in mathematics by S3 students of a certain school in 2023. So this is the table of values. We are drawing the table. We have marks, which is out of 100. Then we have number of students Another name for the number of students, this is sometimes called the frequency. Then class marks. Another name for the class marks is sometimes called the midpoint. Then Fx. Remember, the class marks are represented by letter X. So this is the table of values. Now, in the first column, we have 10 to 14, we have 15 to 19, 20 to 24, 25 to 29, 30 to 34, 35 to 39, 40 to 44, 45 to 49. 49. These are the classes. Now, number of students has been given that represents the frequency. We have 8, we have 6, we have 14, 18, then we have 10, 12, then 8, and 6. This means that 80 students got marks ranging from 10 to 14. Those students who got marks ranging from 15 to 19 are 6. Those who got marks ranging from 20 to 24 are 14, and so on and so forth. That is how that column means. Then we have class marks. The class marks, we don't know them, and we are to fill these gaps. We don't know the values of the class marker, the class mark values. Even fx, we don't know. So we want to see how we can fill this table.
Now, to fill this table, remember from the idea which we have on class marks. Class marks, we said another name for it is the midpoint. And we said that to obtain the midpoint, we add the lower class limit to the upper class limit, then we divide by 2. That is how we obtain the class marker values, or what we call the midpoint. In this case, the lower class limits and the upper class limits are found in the first column. For example, for the first class, 10 represents the lower class limit, 14 represents the upper class limit. So we add 10 plus 14, we find that we get 24. And 24 divided by 2, we get 12. So we write 12 here. That is the first class mark value. Get the second class mark value, we add 15 to 19. 15 plus 19, we find that we get 34. And the 34 divided by 2, we get 17. So normally, the quickest method is, once you establish the first value and the second value, to get the third value and the rest of the values, just to get the difference between the first value and the second value. Then you keep on adding it to simplify 1. So here we shall say 17 minus 12, you get 5. So that 5, you add it to 17, you get 22. Plus 5, 27, plus 5, 32, plus 5, 37, plus 5, 42, plus 5, 47. It is just less than a minute when you have computed it. Then we can now go to fx. Fx means the frequency values times the class marker values. So the frequency values are, here we shall multiply 8 times 12. 8 times 12, we shall find that we get 96. 96. 6 times the 17, we shall get here 42, you carry 4, 6, 10, which is 102. 14 times 22. 14 times 22, we find that we obtain 308. 308. Then we come here, 18 times 27, 18 times 27. We get 486. Then we come here, 10 times 32, we get 320. 12 times 37. 12 times 37, we get 444. 444. 8 times 42. 8 times 42, we get 336. 336. And then 6 times 47. 6 times 47, we find that we get 282. 282. So we have filled the table. Once you do that, you will have answered the question. However, down here they want us to get the total frequency. Total frequency, which is summation F. Then also they want us to get summation Fx. Summation Fx is equal to, so here we add the total frequency values and we get, this is 14, 14 plus 14, 28, 28 plus 18, we get 46, then plus 10, we get 56, plus 12, we get 68, then plus 8, finally that we get 76, then plus 6, we find that we get 82. So you write 82 there. That is the summation f. Then summation of fx. We add 96 plus 102 plus 308 plus 486 plus 320 plus 444 plus 336 plus 282 plus 282, then we get 2,374. 2,374. This one will be summation of f of x. So you will have answered the question. So remember the question was saying copy and complete the table below. Hence calculate the mean mark and the mode for all the students. So from that table we have to calculate the mean mark. We have already completed the table. So to calculate the mean, we know that the mean, which is the x bar, is equal to by summation of fx divided by summation of f. Then we substitute summation of fx is 2,374 divided by summation of f. We find that it is 82. So when we divide 2,374 divided by 82, we find that we get 28.95. Which when approximated, it will give us 29. Remember, we are dealing with marks. So that is 29. These marks are in what? In percentage. So that is 29%. That becomes the what? The mean mark. They also want us to calculate the mode or the model mark. To calculate the model mark, what we shall do, we first establish the value of the model class. We first find the model class. So after finding the model class, it is in the model class where the mode lies. So the model class is the class corresponding with the highest frequency. So when you look at the frequency values, we find that the highest frequency is 18. So 18 corresponds with the class of 25 to 29, meaning that this class of 25 to 29 gives us the model class, and that is where the mode lies. We can now calculate that. Let's now calculate the mode. So we know that mode is obtained from the model class. So we first define the model class. Model class is the class with the highest frequency, which is 25 to 29. 25 to 29. Now, in the model class, after writing it down, we shall now obtain what we call the lower class boundary of the model class, which is represented by letter L1. L1. And L1 is obtained by subtracting 0.5 from, by subtracting 0.5 from the lower class limit. We subtract 0.5 from the lower class limit. In this case, our lower class limit is 25. So 25 minus 0.5, we find that we obtain 25 minus 0.5, we get 24.5. 24.5. So the 24.5 is the lower class limit. Then we shall obtain also D1. We said that from the definition of D1, D1 is the difference between the frequency of the model class and the one before it. In this case, the frequency of the model class is 18. Is 18. The one before it is 14. So therefore, 18 minus 14 is equal to 4. So 4 is D1. Then we also calculate D2. D2, we said that is the difference between the frequency of the model class and the one after it. The frequency of the model class is 18. The one after it is 10. Therefore, 18 minus 10 gives us 8. So the 8 is the D2. After getting the D2, we need to get now C, where C stands for the class interval of the model class. Class interval is obtained by the upper class limit minus the lower class limit plus 1. Or you can obtain it from the upper class boundary minus the lower class boundary only. So in this case, our class interval is 29 minus 24 plus 1, which is equal to 5. 29 minus 25, then plus 1, which is equal to what? 5. So the last interval is equal to 5. After that, we now write down the formula for finding the mode, which says mode is equal to L1 plus D1 over D1 plus D2, then everything times C. So when we substitute, where there is L1, we shall put 24.5. 24.5 plus D1, where there is D1, we substitute 4 over D1, which is 4, plus D2 plus D2. D2 is 8. Then everything times C, which is C, we say that is equal to 5. Then we compute this. We add this to 8. So when we add, we will find that 5 times 4 is 20. And 20 divided by 12. 20 divided by 12, we get 1.6667, then plus 24.5. 24.5 is equal to 26. 26.2. 26.2%. So this gives us the value of the mod. So to prove that the answer is true, when we look at the 26.2, it is a figure which lies within the model class. It lies between 25 and 29. So that gives us the value of the mod. Part B of that question, they want us to obtain the cumulative distribution table. Then use the table to find the median mark, to find the cumulative frequency table. So in this case, to find this is what we do. We shall wrap off this first. Okay. So to find the cumulative, to obtain the cumulative distribution table, we shall just add a column. We add a column to this one. So this is the column for cumulative frequency. Now, to obtain the column for cumulative frequency, we cumulate the values of frequencies. So we first write the first frequency, which is 8. Then we add it to the second frequency. 8 plus 6, we get 14. This 14, we add it to the second frequency value, which is 14. And 14 plus 14, we get 28. 28 plus, we add it to the second frequency value. 28 plus 18. We find that we get 28 plus 18. We get 46. The next will be 46. Then this 46, we add it to the next frequency value, which is 10. So 46 plus 10, we find that we get 56 here. The 56 plus 12 plus the next frequency value, which is 12. We find that we shall get 68. 68. 68. Then this is 68 plus the next frequency value, which is also 8. So 68 plus 8, we find that we get 76. Then 76 plus 6, we find that we get 82. So this is final value, which is the 82, must correspond with the total frequency. This one has answered that part of adding the cumulative frequency column. Then they want us to use now this cumulative frequency table to calculate the median. So let's now calculate the median. To find the median, this is what we do. We use the formula. To calculate the median, we need to know first of all, we need to establish the median class. The median class is the class containing the median. And how do we obtain the median class? To obtain the median class, we first find the median class. So median class is obtained by the formula summation f over tooth observation, or n over tooth observation. Then n over tooth observation, where n stands for the total frequency. So our n is the total frequency, which is 82. So we divide it by 2. So which gets us 82 divided by 2, we get 41 fake observation. So it means our median is the 41st observation. The 41st observation. Now, in this case, let us write it the way it is supposed to be. Use corrective grammar. 41st. So we put here 41st observation. 41st observation. So now we are going to look for the first 41st observation. Where do we get the 41st observation? To get the 41st observation, we go to the cumulative frequency column, which we have just developed. Then we look for where 41 is. Now, if 41 is not exactly there, then you consider the neighbor of 41, the figure which is near 41 but above it, is what we consider. In this case, you find that 41 lies between 28 and 46. So we take 46. The neighbor of 41, which is near but above it, is what we consider. So, which is 46. Now, in the 46, you correspond it, you move your eyes to the left. 46 corresponds with the class. So you can say that 46 corresponds with the class of 25 to 29. So 25 to 29 is the median class. So median class is equal to 25 to 29. The same as the model class. So now, after getting it, from the median class now, then we determine the lower class boundary of the median class, which is equal to by 25 minus 0.5, giving us 24.5. After that, we shall obtain, first of all, the value of n we know, which is summation f, which is 82. Then we shall obtain C, the value of C, or what we call FB. We said that FB, remember, stands for the cumulative frequency before that one of the median class. So, the cumulative frequency of the median class, remember, is 46. But the one before it is 28. So we write 28 here. FB is equal to 28. Then also we shall get FM, where FM stands for the frequency of the median class. In this case, our median class is 25 to 29. Its frequency is 18. Put it there. Then also we write down the class interval C of the median class, which is the same as 5. After, now we substitute these figures in the formula. we substitute the figures in the formula. We substitute them. FM is 18. FB and 82. Now, so we are now going to substitute this in the what? In the formula. So our formula says okay. Let us delete this. This information we still want it. Okay. So remember, median of group data is obtained by the formula N1 plus N over 2 minus FB all over FM then times C. Then we substitute. Where there is L1, we shall put 24.5. 24.5 plus N is 82 over 2 minus FB, cumulative frequency before, which we say is 28. All over FM is 18. Then times now C, which is 5. Then when we simplify this, we shall find that 82 divided by 2, we get 41. 41. And 41 minus 28, we get 13. Then 13 times 5, we find that we get 65. And then 65 divided by 18, we find that we get 3.6. And then 3.6 now plus 24.5, we find that we get 28. 28.1, which is approximately 28, and we can say that 28 lies within this class, between 25 and 29. So this gives us the value of the what? The median. So therefore, median is equal to 28.1%. That would be the value of the median. So, our lesson of today has ended here. Next time, when we meet, we shall look at presentation of data, how we present data, ways of presenting it, that very good for this.